You can see the title and you're at the right place. Really quickly, a show of hands. Is there anyone here that doesn't use Postgres? Okay. Jump right in. So a few just completely shameless plugs at first. So I do a good bit of writing about Postgres, among other things, on my personal blog. Hopefully it's a helpful resource. I curate something called Postgres Weekly. So this is a little different from the one that hits the Postgres mailing list. It's more end-user content, kind of how-tos. It's not what's going on the hackers list. It's more curated at end users. I like to think it's a pretty good resource. Postgres Guide is another thing. If you're on a Mac, give Postgres.app a look. Hopefully it makes your lives much better and happier than Homebrew or Mac ports. And then I work at Heroku. Has everyone here heard of Heroku? Okay. We run essentially the largest fleet of Postgres in the world. So if you don't want to deal with all the administration, we pretty much take care of it for you. So I travel a decent bit and speak at quite a few conferences. And when I'm talking about Postgres, I usually put up a slide like this. Either at the beginning or the end as kind of the why is Postgres great. If many of you are in here for Magnus's talk, there are not nearly enough hands go up for some of these things. Extensions, in particular, like HStore, it's a key value store directly in your database. I think Magnus at his conference yesterday was talking about you shouldn't use your database as just a key value store, and it's a perfectly good one. We'll get into a little bit of that and how with indexes it can work pretty well. Common table expressions are awesome. Window functions. If there's things up there that are surprising, write them down, search for them. You should probably know about maybe every one of these features if you're using Postgres, just because it can make your life better if you know what to look for. So digging in, there's kind of two general workloads for any database, OLTP and OLAP. OLTP is essentially web apps. So this is mostly where I'm going to focus on for the next while. OLAP is a perfectly valid place and needs performance considerations as well, but it starts getting much more varied and deeper much quicker. And so I mean, in the OLAP world, you're looking at BI and reporting. I'll give some general rules for it, but it's essentially a whole other talk that we could dig into. Really quickly here, are people more on like the web application side here, or are they doing more OLAP? How about web side? Okay. People doing data warehousing type things? Okay. So sorry if I disappointed any of you in this on the latter half. Hopefully there's a little bit in here that's still useful. So really quickly on Postgres setup and config. I'm not going to dig too much into this because there's some guides basically on what to do and basically copy and follow along and then don't worry about it. So if you're on Amazon, shameless plug again, use Heroku or look at Christoph Pettis' talk, PostgreSQL when it's not your day job. Basically set about 50 configurations and then you're good. And then you don't have to worry about it. For other clouds, look at his talk. And if you're on real hardware, so good performance machines, Christoph's talk can be a good starting point. But to really optimize it, high performance PostgreSQL. This is a book by Greg Smith. It is pretty much the de facto for tweaking and tuning configuration of Postgres. It's based on 9.0, but it's still pretty relevant overall. And there's the link, and all the slides will be up online as well after, so don't worry too much about links, but there's the link to Christoph's talk. So generally when looking at a database, I work with a lot of customers and they'll say, I'm having performance problems, and I think the first thing to do is to take a look from the 30,000 foot view, like the nice far away, how healthy is the system overall? And I think the number one thing to pay attention to here is the cache. So Postgres is really good about keeping frequently accessed data in memory. If you were in Magnus's talk before this, he mentioned pre-warm, which is huge when you fail over to a read slave that hasn't been receiving traffic. Your performance is basically going to go to crap. So pre-warming that before you fail over every so often is really nice. Postgres is going to do a better job of this than you are. You don't have to think about it. It's pretty intelligent. It's going to keep your frequently accessed data in cache. And you're looking at a 1,000 to 1 performance difference if you're hitting cache first, having to seek to disk. What we've seen is generally data follows the 80-20 rule. So you don't need as much memory as the amount of your data. A lot of your data is going to be pretty frequently accessed. It's kind of rough, but generally 80% of your data should be in cache. So the cache hit rate, there's a nice simple query to get it. You can Google, you can find this. If you're on Heroku, we have a plugin called PG Extras. You can just view the source and grab this query from there. It's going to give you something nice and simple that looks like this at the end of it. And what you're looking for is somewhere around 99% or higher. As soon as you start to dip below that, you're going to see pretty significant performance degradation on your queries. The other one is index hit rate. So how often are you using indexes versus sequentially scanning a ton of data? So this one's a little bit prettier and going to give you something that looks like this. So on this one, indexes, I would say, follow a little bit of a different rule. Right here, I would probably say on anything that's over those top 3 tables, they're performing horribly. I'm doing a sequential scan over a few 100,000 rows. And this is actually a real-world example from an app that we had where queries, I think, were taking about 3 seconds, adding some indexes on them, dropped it down to, I think, around 10 milliseconds. So that's what you're typically looking at there. I'll get into kind of a rough rule of thumb for it in a second. So I mentioned the 80-20 rule. I would say rough guidelines. Cache hit rate, you're going to want it to be at 99% or higher. So anytime looking at a database, if I can get it to 99% by just throwing more memory at it, my life's going to be a lot better. Index hit rate, looking at 95% or higher. And I put the where 10,000 rows there kind of in gray. This isn't a hard and fast. Doing a sequential scan across 100 rows isn't too bad. Sometimes, if you've got 10 rows in a table, the sequential scan is going to be faster than your index. But it's not going to hurt heavily to have an index on every single row if you're frequently using it as well. So I mentioned some of those queries, the cache hit, the index hit. I generally recommend just saving these and using them all the time. A nice thing to do, how many people customize their P-SQL-RC here? Okay, cool. So hopefully this isn't news. It's basically setting like a query name, and then I can just select from that. So the bottom one right there. Really nice to save these, so if you're on your own local machine and things like cache hit, index hit, slow queries, we'll get to this one in a little bit, but super handy and just can save yourself so much time versus Googling for it every single time. One really quick detour, Datascope is an awesome tool for visualizing this cache hit, index hit, and some other things. It'll actually track it, visualize, overlay, look for things like block contention and other stuff. Just pull it down from the GitHub repo, install it. It should be pretty straightforward. So from there, the obvious thing is cache is decent, indexes are decent, but some things are still slow. So understanding specific query performance. How many of you understand what an explain plan looks like in Postgres? And can read it and make sense of it? There was a lot of really unsure hands there. So a pretty basic query. So for those of you that aren't familiar, every query has a query plan, and explain will show you what it thinks it's going to do and run like. Explain and analyze will show that to you in Postgres, the actual path and how long it took at each step. So this is what one looks like essentially. And I think when I've showed this slide once before, well, I'll talk about that in a second, but I get yelled at because I haven't analyzed my data. So it'll show the cost there, and the cost is what it roughly thinks it's going to do. It's actually in some measurement that I don't understand. I don't think it's in actual milliseconds like it is on Explain Analyze. It's some weird costing setting internally to Postgres, but you can generally judge it the same way. So super confusing, trying to simplify it down. The initial cost right there is the startup time for it. The middle is the max time, and on the right is the rows returned. I believe in 9.2 now, maybe it's 9.3, it'll show rows excluded as well sometimes on Explain Analyze when it discards rows, which is very helpful as well. So this is nice and marginally helpful. The real value is Explain Analyze. The difference here is it's actually going to execute the query. So if this is a query you don't want running on your system because it's going to take down production, then well, don't do this with it. It's going to run it. But it's also going to show the actual time. So you've got the estimates up there that we saw before, and it's going to show you the actual time that it took for each step there. So you can start to say, certain things that right there, 295 milliseconds. I'd say this is actually pretty bad for what it's doing. It's returning 3 rows in total, which is pretty poor. So that actual time there is what you want to pay attention to, and rough rule of thumb there. For most web applications, you're looking, page response times, I would say you're looking to get under 100 milliseconds. So common queries under 10 milliseconds. Rare queries under 100 milliseconds. And this entirely changes in the data warehousing world. But on small kind of result sets, this should be pretty much what you're aiming for. And I'd say common queries, you can get them down very close to 1 millisecond pretty commonly. But at that point, you start kind of micro-optimizing where you could be solving bigger problems. So as I said, that's a pretty bad time overall. Enter the obvious thing, indexes. So creating an index on this, you're going to see it start to change. So it's going to use an index scan now, and it's going to bring that time down to 1.7 milliseconds. So there we're looking at a couple orders of magnitude shaved off, which I think is where you want to optimize. So any query, I'm looking at how many orders of magnitude versus just raw seconds. So Magnus also mentioned this in his talk, and there were ways, I think it was a mix. So there were some people that were aware and using it, but still way too many. I don't think you should, if you have Postgres installed, you should be using this on a probably weekly basis. So PG stat statements normalizes every single query that's run against your database. So if I actually have something in there, like select star from users where email is craig@heroku.com, it's going to replace that craig@heroku.com as you see right there. And it's going to record a ton of information about it. It's going to record the number of times it's run, the average time that it takes, number of I/O blocks dirtied, written, all of these things that are interesting. But I think the most interesting thing is that you can, with a very, very simple query, get an insight of where can I get the best cost savings on my database. So hopefully this is fairly straightforward. It's basically going to take the total time of every query, render that as minutes, take the average time that it takes, so I can start to tell where do I want to optimize, and then how many times it's run as well. So that's going to start to give something like this, assuming the full query is out there. So you can see that I've got 295 minutes on the first one against my database, and 10 milliseconds on average against each time it's run. Looking at those two things, I can pretty much tell where I can give myself a ton back. I actually probably wouldn't optimize the first one, and would just jump down to the second one since the total is close enough, and I can probably get 2 orders of magnitude back. Has anyone in the room looked at their database like this and taken advantage of pgstat segments this way? Okay, a few people. This is a super easy way just to know where are you spending time and where can you get it back on your system. All right, so indexes. Postgres indexing is really awesome. There's quite a few types. B-tree, Gen, Gist, KNN, SP, Gist. And I hear Vodka is coming along as well, but I don't know when. Or at least it's rumored by the crazy Russians that create all of the index types. If you're like me, though, the first time I looked at this, this was kind of my response. Like, this is great, and it was explained to me, and I still didn't quite follow when to use which. And they have entirely different implications of, will it actually help performance, size on disk, and other stuff. I think Christoph talked a little bit about HStore and Gen and Gist earlier on performance. I'm going to boil it down hopefully much simpler, and this isn't a perfect rule of thumb. B-tree, it's usually what you want. When you say create an index, this is what you're going to get. In most cases, this is what you want. Use it. Don't worry about it. Gen. So for those using arrays or HStore, if you're not using HStore, take a look at it. It's awesome, like I was saying earlier. It's essentially a key value store directly inside your database. So you can shove a dictionary right in there, and it just works. So Gen generally is when you have multiple values inside a single column. So array, HStore obviously makes some sense there. Gist. Here's where you have essentially a couple, like a 2D thing that can overlap. Full text search, shapes, rough rule of thumb, where it can kind of fall under multiple different ones. KNN is for similarity. SP Gist, I think I've had that explained to me 20 times and I still vaguely understand it. I hear it's good for phone numbers, so when you've got kind of different densities within different subgroups, it's the best I can do there. And I'm sure there's some people in the room that maybe can explain it better. I would love to hear from you afterwards. But I hear it's good for phone numbers, so if you're doing anything with phone numbers, give it a try. But then there's a few more indexes, right? So there's your index types. There's also the ability to do conditional and functional indexes, which for a ton of applications are hugely applicable. So conditional ones, basically, if I'm selecting star from places, maybe I only want to index my top cities. I want to index places that have a population of over 10,000. So this is going to keep that index for only where that condition is true. So creating it, pretty straightforward. Create it on the table, put it in the column, and put your condition there. You can actually have functions on this as well. So functional indexes also equally as awesome. Is anyone here using JSON in production? Few people. I'm betting it's not performing well for you unless you're doing some functional indexes, or unless you're just shoving a raw JSON blob. So JSON in Postgres is getting better. Hopefully when we have JSON B, it actually gets a lot more performant. But right now, JSON is it's not going to take advantage of a gen index or gist index just because it's text. With functional indexes, with something like PLV8. So PLV8, for those not familiar, is the V8 JavaScript engine embedded directly into Postgres. So you can execute whatever JavaScript you want, which is awesome if you're using JSON. So using it, you can start to do things like this. So I've got a basic JSON blob down there. I can create a function called getNumeric, which is actually going to traverse down into the JSON, pull out the key population from my column data, which data is an awful column name, except I think it works for JSON because there's still all sorts of random data down in there. And so in this case, I'm actually combining, the functional index, or no, I'm not. Let's see. So here we go. So you can create the index on that function, and it's going to do what you expect there. One probably important thing is declaring it as immutable. Immutable essentially says if I pass this same thing in, I'm going to get the same result out. Versus if your function has the ability to do random things, to write data, to change data, which there are some valid cases for, you're gonna suffer then. Essentially, it's not going to be able to be immutable, and Postgres is going to optimize for that differently. So if you've got something that always returns the same result based on the same input, then you want it to be immutable because you're going to get the performance gains there. And then, of course, you can combine them. So you can do conditional combined with functional indexes. Pretty straightforward. Create index concurrently. Is anyone here not aware of this? Does anyone have friends that use MySQL? Well, friends may be the wrong word. This is the single easiest way to convince them. So hopefully I'm preaching to the choir here, but it's going to be roughly 2 to 3 times slower. And when I say it doesn't lock the table, it doesn't take a lock the entire time on the table. It's going to take a lock, but it's essentially unnoticeable. And it's going to build up your index in the background. So you can keep writing data, keep doing shit, and you don't have to worry about bringing down production for a day or two while you try to improve performance, which certain other databases I hear can happen. So another big thing is pooling. Does everyone here? I'll just get into it. This is a new relic performance chart. And right there at the bottom is the connection time from PsychoPG2. And this is pretty normal. So some people have commented that it seems really high. The bulk of the cost there is SSL negotiation, which does have some overhead. But this was the default for a long time in Django, that it would grab a connection on every request. I would say there's a couple options here to fix it. There's the application framework layer, which often has connection pooling. So I think Rails does by default. The SQL and Ruby library. Django now has persistent connections, which is better in 1.6. I think the Play framework has persistent connections. I would look at your language framework. If it doesn't have it, figure out how to get it in there. It should just be a default. But the other is a standalone daemon, and I think this is what most people think of when they think of connection pooling. In reality, both can work and be useful, and larger applications will have both. A general opinion, I'd say you don't need the standalone daemon until you're maybe at 100 connections or more. And there's varying opinion there in the Postgres community. So on the Postgres daemon side, there's 2 options pretty much. PG Bouncer, PG Pool. I'd pretty much say PG Bouncer is what you should be using. I'm sure people may disagree with that, but it's kind of a one tool for the job, which is nice, where PG Pool does a lot of different things and comes with a few more caveats. So you need to know a little bit more about what you're doing. So as I mentioned early on, like cache is important, and it's probably the most important piece in paying attention to when building OLTP applications. The easiest way when performance is crappy is to just add more cache, throw more hardware at the problem. One kind of nice option of doing that is replication. So replication has gotten a little bit better in Postgres. But the nice thing when I say, replication and then cache, you can send read queries to a slave. So if you can handle 10 milliseconds, 100 milliseconds of latency from the time it's written to the time it's read, which most applications can, the read slave is going to have its own cache and optimized for that, which can be very, very nice. So when it comes to replication, there's quite a few options. There's Sloaney, it's supposed to be Londiste, that's a typo, Picardo, PG Pool, and Wally and Barman. Personal recommendation, if you're not already using replication and wanting to get started, I would start with one of those two. They're simpler to run. Again, it's that really small, lightweight tool, so you don't have to worry about too many things. You'll know when you need the others generally. If you're just setting up for replication, they generally just work. And they work with the Postgres streaming replication, and are just some nice tooling around it to make it a little easier to set up. So in updating Postgres settings, I encourage most people, if you're not comfortable with looking at a Postgres config file, I encourage you, not to look because it's scary. When you do need to update settings, there's essentially just a few I would really generally start to point people at. I'm not going to go into super detail because I think the Postgres docs actually explained them pretty well overall. But essentially, optimizing your cache size for your database and what's allocated, shared buffers, work mem and maintenance work mem, though apparently now it's going to be auto vacuum? I forget what it is now. The new one in 9.4, that's essentially for auto vacuum. But work mem is going to be, if you're doing a little more OLAP stuff, you're going to start tweaking and optimizing there a little bit more. So on backups, that's another area that actually has performance implications. Most people just add them automatically to their database, which is a good thing to do. I'm not saying get rid of your backups, but there's a couple types of backups, and it does have some implications. So the first one, I think, is this is what most people really do. It's what's called a logical backup. So this is going to be a PG dump of your database. It can be human readable. It doesn't have to be, but can be human readable. It's portable, so you can take it, restore it locally, cross-platform. It just works. This is what most people do. The other option is physical. So this is the actual bytes on disk. It generally is said to be kind of architecture dependent, that you're on the same one. I've heard rumors that it can work across ones, but I don't think anyone in the community commits that works. So basically, you're going to have the same infrastructure there to restore to it. So it's not for pulling from a production setting down to your development laptop unless it's identical. But this is the actual bytes on disk. And the base backup by itself is often useless. You need some of the write-ahead log as well to actually take advantage of it. So kind of comparing and contrasting the two. Logical, it's good across multiple architectures, good for portability. It has load on the database. It has fairly significant load. And I think the rule of thumb in the community, I would say it works for under 50 gigabytes. If you're over 50 gigabytes, it's going to start failing on you, and not perfectly consistently. And it's just going to get worse over time. If you're up in the terabyte range, I'd be shocked to hear if you're doing a PG dump and it actually works. So it starts just failing. But the really nice thing about logical backups is because it is human readable and portable, it's actually going to do some validation on your data. So it's going to be a way to find corruption. So I would encourage people to do it, but do it on a once a week, once a month basis. Checksums now in 9.3 definitely help for checking for corruption. But if you're on an older database, this is probably the best way to actually find it and isolate it. And then physical ones, more initial setup. There's definitely some more work early on than just PG dump, but it is less portable. But it does have limited load on the system. So I think as you scale, this is really where you want to be. The other thing is physical backups are typically what enable the replication setup, and just a good thing to do. So I'd encourage, not necessarily one or the other. You shouldn't be looking at them, but what combination of both do you need? So for us, we actually do base backups daily, and we do logical backups. It's kind of up to the users, but I encourage a once a week, once a month type thing. So I actually blew through all of that, but I'll kind of recap it all and plenty of time for questions. So for OLAP, like I said, it's essentially a whole other talk. I mean, I think the key principle is there. If you're doing something in data warehousing, disk I/O is going to be typically pretty important to you. The order on disk is helpful. There's an interesting tool that I'm not sure if I would encourage using. PG Reorg, it comes with a lot of caveats where you can essentially ruin your entire database if you do it wrong. But it is really awesome, and I think we're moving towards a little bit of that functionality to appear in core over time. There's some interesting things there, but I don't think the full functionality is coming anytime super soon. And the other thing is you start to get more and more hardcore is MPP solutions on top of Postgres. These can be private commodity products, or they can be homegrown solutions with things like PL proxy. For OLTP, the basics, ensure your data is in cache as much as possible. So 99%, and I think for us, anytime we see someone drop below that, we encourage them to upgrade. Optimize your query load with PG stat statements. I would solely start with PG stat statements. I wouldn't look at one-off queries. I'd look and see how much overall load they have on the system, unless for some reason there's one report you really, really care about. Efficient use of indexes, and then when scaling, I think any database, the easiest way to scale it is to throw more money at the problem. It actually does work. Databases need memory and work pretty well with it. And so all the slides should be online. Speaker deck, Craig Kirstein's. And I'll open that up for any questions.
Do you recommend using stat statements in production systems?
Yeah, I definitely recommend using PG stat statements on production systems. It's got some overhead, but it's pretty low overall. And I think the overhead that it introduces, you'll easily get back as you optimize. We've started turning it on for every single customer by default because it is so valuable. And inevitably, you're going to say, how do I optimize to my database? And having that data already there is hugely valuable. Yeah.
Can you add something to what you said before about PG dump not being reliable above 50 gigabytes? Can you talk more about what you meant by that?
I mean, it won't dump. The question, in case anyone didn't hear it, was, can I elaborate a little more on PG dump not being reliable over 50 gigabytes? And at a certain point, it'll just fail. It won't give you a dump, and it won't really clearly say why either. PG dump doesn't have the best error reporting, so sometimes it'll work, sometimes it won't. And typically when you get to that size, it's usually the one large table problem. You've got one table that's just really, really huge, and for some reason it just doesn't work well with it. I think there's some improvements being made to help. It also fails when you have thousands and thousands of tables. So some of the management with getting that information from the catalogs doesn't work very well. So essentially, you're just going to get nothing, and you're going to know it's not working. But the solution isn't to try to keep inching it along more and more and more. It's to start to go the other way. Yep.
Is there some news about performance regarding thousands
So the question, in case anyone didn't hear it, was do I have any input kind of on which file system should be used for Postgres?
layout? How should be?
Yeah, so file system layout. I think it really depends on a lot of things of what you're doing. I'd say look at Christoph's talk. He gives a pretty basic version of if you're on cloud drives, do this. If you're on these shittier cloud drives, do this. And if you're on real hardware, do this. Essentially what you're doing there is you're just setting the some of the page cost settings of how long does it typically take to grab a page. And once you tweak that for what you're on, Postgres will pretty much do the right thing with the planner. In terms of, is there a preferred file system to run on? I think that's probably a huge bike shed, really. That there's a ton of different opinions. I'm trying to think offhand of what we run on, and it's escaping me.
As I noticed, someone recommending keeps the best over export.
Yeah, I think you're going to find people in all camps. I don't have a strong opinion personally there, but check with me after, and I can double check what we run on, and probably get some more information on why.
Is Hero using PG dump for the automated backup?
Yeah, so for automated backups, we use PG. Well, it depends. So for all of our customers, we do base backups every 24 hours. And our customers don't see that. We just do it. We manage it. We worry about it. They don't have to think about it. Because people like to feel and touch and hold a backup, we have something called PG backups for Heroku, and that is a PG dump one. And that's because people do want to pull their data down locally. I'm not discouraging the use of PG dump. Just know that it has load on your system. Know that you should be doing other things, and know that it will stop scaling for you at some point. I think a lot of people add it on a daily backup and then set up replication as well, where replication should lend itself to replace some of that. And by running PG backups PG dump on a daily basis, you're introducing unnecessary load. And we have a request every so often come in, hey, can I run this backup every hour? And it's like, why? You don't need it. You're not going to recover that way. There's a better approach. So yeah, it's there. Users use it. It's helpful for moving data around, but it's not our default backup option. Awesome. Thank you, guys.
Thank you.
Christoph? If you search for PostgreSQL when it's not your day job, you'll find it. It should be, yeah, that link is it. But if you get to my slides, that link's on there. Okay. Thanks.
My problem is I'm really able to fast reading disks because we have DBs over 100 gigs and basically I have huge sequential reads over above 20 million records. So in this case, my main issue is how fast I do read from disks.
Yep.
And to make things worse, I constantly sometimes delete something from that database because it gets overblown.
Yep. Yeah, so there I would definitely that's where Greg Smith's book becomes really handy. Greg does a lot on if you've got, are you on your own hardware?
I have that book.
Okay. Greg's book is the best source there. I hear he's updating it. I don't know when it's happening, but I know he's working on an update for it. I can take the hint. I can tell when I'm not wanting. No, sorry. No, I'm kidding. No, I wasn't.
Are you Craig?
Yes.
I'm Kathleen.
Oh, nice to meet you.
Nice to meet you as well.
How's it going so far?
Good. Busy. Good.
Just a very quick question. Induction. So what's really happening with the induction app?
It's not. I mean, Postgres still maintaining.
Yeah.
Induction was kind of a nice prototype, but Matt, I know, is generally spending a lot more time on other things.
Yeah. So I gather.
But I'm actually working on a blog post around Postgres kind of query GUI tools.
Yeah.
Like if you're on Postgres Weekly, you'll see it. It'll be up in a week or two. Because there's been a few pop up. There's been 3 or 4 pop up, and some are better than others. But I think they're all improving.
Yeah.
So trying to actually review all of them and say which ones are nice or not.
Okay. Very cool.
Induction, I don't think is getting a lot more updates super soon.
No. Yeah. No. The promise was kind of cool.
I agree. And it's something I definitely want to see keep improving and change. Because right now the state of GUI editor sucks.
But actually, it was a gist that Matt actually published at one point, where he actually revealed the sort of future look of the. And maybe it was like a private branch, but it didn't push or something. So.
There was another sprint on it that he was making, but it never. There was various problems with it.
Okay.
Yeah.
Okay. Cool. So I'll stay tuned to Postgres Weekly. Cool. Thanks a lot.
Hi. I was just wanting to ask about a quite special use case I have. I try to use Postgres basically as in-memory manipulation engine because I just load the data, use some manipulation. You could say it's OLAP or not really, but I don't really need consistency or anything. Okay. Just transform it and dump it out.
Yep.
So if you have any tips about this and keeping it in memory?
It has an in-memory mode.
It has fsync off.
Well, no, I think there's a full in-memory mode for Postgres, but I can never remember how to run it.
No, you can also use RAM disks.
Yeah.
So you play.
But there's another way. It started actually all in.
From what I read online, I think in the official documentation about consistency, they say don't use RAM disk. These are the options
but
which
you're using in memory.
Yeah.
Otherwise, you're not interested in consistency of that particular set.
Yeah, there's all these fsync off and delay before.
There's synchronous commit mode that you can disable. So on fsync, basically you have a synchronous
running in Mongo mode.
It's the MySQL mode.
I mean, I don't know if anything immediately comes to mind, just because. I think a lot of people will run just fsync off because it's okay, this works well enough. It's probably not going to lose data in that time. Load it to memory, run it, and then you're good. That's the people I know that have done similar things have done that and been okay with it, and that usually works well enough for them. But I don't know that there's anything a whole lot better. And there you have some risk of some corruption, but if you're just loading it up and then running the implementation, 99% of it.
I was late.
Fine.
I thought I was at the desk.
But yeah, I don't know anything super more elegant or better.
And I go to Magnus, I go Magnus.
Right off. So, yeah, I would look at. Are you running in that mode now or not?
Yeah, I'm just playing with it. So,
yeah, I think that's the right general direction. I want to say I know of 1 or 2 people that have done that, and that's basically the direction they went. But I don't remember definitive results from them how that went. Cool.
Well, I think we've
like not really decentralized. There's like 2 or 3 people in the whole project. Like, yeah, very low. It's one of any one of the 3 people in the whole project. So you've got OMX, right? You've got some like yeah. So there is one that so now on like our yeah. So it's this like it's really the guy who writes them works for Johnson and there's no more confidence. So like we thought it was really good. It sounded like it was going to continue to improve. Then I was like contributing instead of just them giving us like code. It's always a mess. So we thought we would handle it. Chris is like, he's like basically, I don't know my weeks. And we were like,
Are you alright, Will? Are you alright?
I think so.
All good? You need help?
We'll see after I plug this in.
So I'll be standing there.
Yeah.
And let me know if you want me to consider 50 minutes or 45 or 40 minutes. So I'll do that.
This resolution is not too
All good?
Yeah, probably. I'm just seeing if I can get the resolution nicer. Nope. It's all shaky. Let's just keep it at that.
1280.
Yeah.
Should put 124, 1024.
This one?
Yeah. Or if you prefer also 800.
This seems good. What's the plug?
Scale it.
Yeah. There we go.
Good.
That's good.
So you have 15 minutes in total. So, and including questions. So let me know whether you want me to notify you for the 50 minutes or if you want to leave 5 minutes or 10 minutes for questions.
Just give me the
total time. So when it's 30 minutes, you speak in, you put in for 10 minutes. Okay, so much less. Okay. Yeah.
I have to ask you if it's okay if we record this?
Yeah.
Cool. Yeah. Cool. English. Oh, my parents were, so you do speak English? Maybe a little bit more. Yeah, no, not enough to have conversations, but I know. Starts at 3. Is there a microphone or just talk loud?
Script's really nice and sublime. I tried to put it so a lack of application, so it's program to be in touch with what I'm doing. And then it's actually made like a 10 like Python file, but most of the other ones just send me like programs and then I'll try and work that. So I tried to explain the virtualized thing. I think that was like the real one. Could not grasp the concept at all. So I think it was when modules installed in the system. You've done outside of it. I was telling you. I was telling you on the way back from the satellite.
Excuse me, is this free? Thanks. 2 more minutes.
Where'd you get this? Where'd you get this?
Downstairs at the information desk.
Ah, right. Ah, yeah. Yeah.